Good morning, myself Dr. B. Jyothi, working as an assistant professor of physics in B.V. Raj Institute of Technology, Narsapur. Our course name is Applied Physics. Topic name is Fundamentals of Quantum Physics. In that, we are going to discuss about the classical free electron theory and the electrical conductivity. This classical free electron theory and electrical conductivity, which are coming under this electron theory of solids. So, what is electron theory of solids? So, this is outline of my presentation. So, classical free electron theory, electrical conductivity, drift velocity and mean free path. So, what is electron theory of solids? So, let us consider solids. In this, electron in outermost orbits of atoms determine its electrical properties. This electron theory is applicable to all solids, both metals and the non-metals. In addition, it explains the electrical, thermal and magnetic properties of solids. So, this electron theory of solids, which is used to describe the structure and the properties of a solid. Structure and the properties of a solids based on this electron theory of solids. So, this electron theory of solids developed in three main stages. So, one is classical free electron theory, another one is quantum free electron theory, the third one is zone theory and band theory of solids. Zone theory or band theory of solids. Band theory of solids. So, in this, first one is classical free electron theory. So, Drude and Lorentz developed this theory in the year of 1900. According to this theory, the metals containing free electrons, which are obeying the laws of classical mechanics. This is the classical free electron theory. So, what is quantum free electron theory? So, Sommerfeld developed this theory during the 1928. According to this theory, free electrons obey the quantum laws. Free electrons obey the quantum laws. And the third one is band theory of solids or zone theory. So, Bloch stated this theory in 1928. In 1928, according to this theory, the free electrons moves in a periodic field provided by the lattice, and the theory is also called as band theory of solids. So, these three theories, classical free electron theory, quantum free electron theory, band theory of solids or zone theory. So, the classical free electron theory developed by Drude and Lorentz in the year 1900. The quantum free electron theory developed by the Sommerfeld in the year 1928. Zone theory and band theory of solids developed by the Bloch started this theory in the year of 1928. So, these are the statements of the classical free electron theory, quantum free electron theory, band theory of solids and the zone theory. So, what are the assumptions based on this free electron theory? The free electron theory is based on the following assumptions. What are the assumptions based on this free electron theory? So, let us consider a metal. So, there are a large number of free electrons. So, these large number of free electrons moving freely within the metals. The electrons revolves around the nucleus in an atom. So, these free electrons assumed to behave like as a gas molecules, obeying the laws of kinetic theory of gases. The mean kinetic energy of free electrons is equal to the gas molecules at the same temperature. Okay. So, whatever we are considering this in this metal, the free electrons are available. So, these free electrons are moves freely within the lattice, within the metal. So, these free electrons which are behave like a gas molecules. So when we consider these and also these free electrons behave as a gas molecules and also obeying the laws of kinetic theory of gases. So when we consider this mean kinetic energy of free electrons is equals to the gas molecules at the same temperature. So then the electric conduction is due to the motion of free electrons only. We are getting the electrical conduction due to the motion of the free electrons only. The positive ion core at the fixed position, the free electrons undergoes in a constant collisions with ion core. So here the electrical conduction we are getting. So this electrical conduction we are getting due to the motion of the free electrons only, and this motion of the free electrons, how the electrons are moving around the positive nucleus means the positive ion core at the fixed position, the free electrons moves undergoes in a constant collision with the ion core. So then the electric field is due to the ion cores in a constant through a metal, means the free electrons moves in a completely uniform potential field due to the fixed lattice. So then the repulsion force, the repulsion between these electrons is negligible due to this fixed lattice. Due to the fixed lattice means the free electrons are moves completely uniform potential due to this fixed lattice. So the repulsion force between these electrons is negligible. So when the electric field is applied, when the electric field is applied to this metal, so electric field is applied to this metal, the free electrons are accelerated. The free electrons are accelerated in the direction opposite to the direction of the applied electric field. So when we are considering a metal, the metal consisting a positive nucleus, it is a constant potential. So the free electrons moves around this positive nucleus. When we are applying the external field, the electrons are accelerated opposite to the applied electric field. So then in the metal, free electrons moves freely through the crystal lattice. When the applied external field is absent, the net current due to the momentum of the electrons is zero. Means there is no movement when the absence of the external field, since they move in all direction. So they are moving in random direction. So in between the two collision of electrons within uniform velocity, during every collision, both the direction, the magnitude of the velocity changes. In between the two electrons, in between two collisions, the electrons moves with a uniform velocity. So when the electrons moves in a random direction, when the absence of the external field, the collisions of the electrons move with a uniform velocity. During every collision, the direction and the magnitude of the velocity changes. So in 1900, P. Drude used the electron gas model to explain the electrical conduction in metals. In 1900, P. Drude made use of the electron gas model to explain the electrical conduction in metals. So let us consider and calculate the electrical conductivity of a metal. So electrical conductivity of a metal. So let us consider a Ohm's law. So it governs the electrical conduction in metals at the constant temperature. The current flowing through a wire is directly proportional to the potential difference V. Potential difference V across the wire. So that is I is directly proportional to the V. I is the current, V is the potential difference. So when we are removing this constant proportionality constant, so we are taking I is equals to V by R. R is the resistance of the wire. R is the resistance of the wire. So this is the Ohm's law. We are taking the equation from the Ohm's law. So the current is due to the motion of the conduction electrons under the influence of the electric field. So when we are applying the external field, so the conduction electrons, the electrons are moving in the uniform direction. So the field E exerts a force, that is field exerts a force, that is E is equals to minus E into E. So on the electrons, due to the application of the external electric field, the electrons are accelerated. So when we are applying some force, means that is in the form of minus E into E on the electrons, due to the application of the external field, the electrons are accelerated. So that acceleration depends on the velocity and the time. So we know the acceleration definition. So let us consider if V is the velocity of the electron, V is the velocity of the electron, and the time between the consecutive collisions. The frictional force acting on the electrons can be written as minus mv by tau, where m is the effective mass of electron. Where m is the effective mass of electron means here the effective mass of electron we can define as a. So this is the mass of the electron when it is accelerated when we are applying the external field. If it is accelerated when the external field is applied to the electron, the mass will be changes, that is the effective mass. So here V is the velocity of the electron, and the t time between the consecutive two collisions. So means, so here the time taken by the two consecutive collisions, that is relaxation time. Our mean free lifetime we can represent it. So V is the velocity of the electron, T is the time between the two collisions. The frictional force acting on the electron can be written as minus mv by tau. So next, using the Newton's laws of motion, we know that F is equals to ma, and when we in the case of this electrical conductivity, we are applying the external field in the form of minus E into E on the electron. So we are equating those two equations, F is equals to ma and F is equals to E into A. We know the condition F is equals to m, mass into acceleration. So acceleration is depends on the velocity. Velocity means the rate of change of velocity. The rate of change of velocity is equals to acceleration. So F is equals to m into dv by dt. We can write it as F is equals to ma from the using Newton's laws. So we are applying the external field from this equation is F is equals to minus C into E. So we are doing the equating both equation, that is F is equals to m into dv by dt, and the force we are applying some external force in the form of minus E into E. So this equation, and we'll get the equation, and this equation we are doing me is equals to minus mv by tau, mv by tau. So we are doing this equation number 1 for suppose, so this equation number 2. So we are equating 1 and 2 equation, we'll get the equation is minus E into minus m into v by tau. So we are doing here m is equals to this one, m is the mass, the rate of change of velocity, that is acceleration, F is equal to ma. Here we are applying this external field. So that is minus E minus mv by tau. So using the steady state condition, dv by dt is equals to dv by d tau is equals to 0. So then we are substituting this equation in this, hence equation 1 becomes V is equals to minus E tau by m into E. E tau by m into E. This is equation number 4. Equation 2 is the steady state velocity of the electron. Equation 2 is the steady state velocity of the electron. So that is the presence of the external field. In the absence of the external field, the electrons have random motion, we know that. just as a gas molecules in the container. So random moving electrons undergoes a scattering and change the direction, and this random motion contributes the zero current, and also corresponding velocity is called as the random velocity. So in the presence of the field, this is the absence of the field. The presence of the field, in addition to random velocity, there is an additional net velocity is associated with the electrons called drift velocity. So here we are adding some random velocity when we are applying the external field, that is called the drift velocity. So this drift velocity due to the applied external electric field. So due to this drift velocity Vd, the electrons with negative charge move opposite to the field direction. So this give the equation, we know that is E equals to, so equation number 2. What is the equation number 2 here? Minus E tau by m into E. E tau by m into E. E tau by m into E. So this is a negative direction. This negative charge moves opposite to the field direction. So this negative charge. So if n is the number of conduction electrons, let us consider how many conduction electrons are available in the wire. So let us consider n is the number of conduction electron per unit volume, then the charge per unit volume is minus Ne. So the amount of charge crossing a unit area per unit time is given by the current density. Means current density is nothing but a current per unit area. Current per unit area, J is equals to minus I by A. So per unit area, one unit value minus Ne, and when you consider minus Ne, so number of conduction electrons is N. So when we define the current density, means current flowing through a wire per unit area. So let us consider the copper wire. This is a microscopic view of a copper wire. So here we are applying the external electric field in this direction. So this is a microscopic view. So this drift velocity is working in this opposite of this external field. So this copper wire, this is a positive direction, this is a negative direction. When we are applying the external field to this direction, so the drift velocity will be occurred in the opposite direction of the external field. So the electrons moves at the Fermi speed and has only a tiny drift velocity and superimposed by the applied external field. So here we have the superimposed. The electrons move the Fermi speed and has only tiny drift velocity superimposed by the applied electric field. So this is the microscopic view of the copper wire. So the current density, we know the current density means electric current per unit area. We know that we already written the earlier slide. So J is equals to I by A. I by A means electric current per unit area. Can be expressed in terms of the free electrons density. J is equals to NeVd. J is equals to NeVd. So here small n is the free electron density, Vd is the drift velocity. Drift velocity will be occurred when we are applying the external field only. In the absence of the external field, we can't get the drift velocity. So if the number of atoms per unit volume means number of atoms per unit value nothing but a number of free electrons for atoms like copper that have one free electron per atom is given by, so small n is equals to Avogadro number into density by atomic mass. So from the formula we can represent current density J is equals to minus Ne into minus E tau by m into capital E. So this is a current density. From this equation we can represent it by J is equals to Ne square tau by m into E. So this is the current density. J is equals, we can represent it by J is equals to sigma into E. So this is where sigma is the conductivity. So from the equation 3, so we can equate the equation J is equals to Ne square tau by m into E. J is equals to Ne square tau M into E is equals to J is equals to sigma into E. So E gets cancelled when we are equating those two equations. So then sigma is equals N E square tau by M. So this is the equation. Okay. So then we know this electrical conductivity. So what is rho here? This is the resistivity. This is the resistivity. Means resistivity and the conductivity both are inversely proportional. So that's why rho is equals to 1 by sigma. So both are inversely proportional. So when we are taking this sigma is equals to N into E square tau by M. So this inversely proportional means the resistivity equation is M is equal M by N E square tau. So rho is the resistivity. So from the equation 1, we can conclude that with the increase of the electron concentration, with increasing of the electron concentration, the conductivity sigma also increases. When we take the equation for the conductivity, sigma is equals to N E square tau by M. In this equation, we can observe this. M is a concentration, electron concentration. Sigma is the conductivity. Both are directly proportional. So then electron concentration is increases. Automatically conductivity is also increases. So tau is equals to mean free lifetime or relaxation time. So time taken by the electrons to consecutive two collisions is called mean free lifetime or relaxation time. So the average distance travelled by electron between two successive collisions in the presence of the applied electric field is known as mean free path. So here the mean free path is a distance. Mean or relaxation time. Relaxation time means it depends on the time. So time taken by the two successive collision is relaxation time. Here mean free path is lambda is the distance travelled by the electron between two successive collision in the presence of the applied external field is known as mean free path. So the average time between the collision is given by tau is equals mean free path or RMS velocity of the electron. So tau is equals to sigma by C. Sigma by C. So C is equals to, we know the RMS velocity according to the kinetic theory of gases is given by C bar is equals to root of 3 kT by M. So let us take the equation number 3 here. Equation number 3 from equation number 3 N E square tau by M. So equation 4 is lambda by C is equals to tau. So then RMS velocity C is equals to root 3 kT by M. So from the equation number 3, N E square tau in the place of tau we are substituting lambda by C. Lambda by C, that is sigma is equals to. This is also sigma is equals to. Then N E square sigma lambda by C. So what is C value here? C value N E square lambda by 3 kT by M. 3 kT by M equals to C equals to M into C. M into C. M into C means 3 kT by M. So we can represent it by N E square lambda by root of 3 kT. So we can write it as M equals to root M into root M. So 3 kTm. Okay. So this sigma. Then sigma is equals to N E square lambda by root 3 m k t. So we know the resistivity definition, that is inversely proportional to the conductivity. So resistivity equals to 1 by sigma equals to 3 m k t over root N E square lambda. So, according to the classical free electron theory, the electrical conductivity is inversely proportional to the square root of the absolute temperature. Square root of the absolute temperature. This is the electrical conductivity equation. Next, so what are the merits and what are the demerits from the classical free electron theory. So we can represent it by the success of the classical free electron theory. So it verifies the Ohm's law. It explains the electrical and thermal conductivities of a metal. And it derives the Weidmann-Franz law, means the relation between the electrical and the thermal conductivities, and it explains the optical properties of a metal. So what are the merits from the classical free electron theory is, it verifies the Ohm's law, it explains the electrical and thermal conductivities of the metals, it derives the Weidmann-Franz law, means it is the relation between the electrical and the thermal conductivities, and it explains the optical properties of a metal. So what are the drawbacks from this classical free electron theory? This phenomena such as photoelectric effect, Compton effect, black body radiation could not be explained by this classical free electron theory. So this classical free electron theory could not explain those concepts, means those are photoelectric effect, Compton effect, black body radiation. The electrical conductivity could not explain with the temperature, means here the electrical conductivity could not explain with respect to the temperature by using this method. So and also the electrical conductivity is inversely proportional to the temperature. While this theory in the earlier slide we predicted that it is inversely proportional to the square root of the temperature. Actually, it is inversely proportional to the temperature. What we proved from this classical free electron theory is inversely proportional to the square root of the temperature. So this is the one of the drawback. This second drawback, and this coming to the another drawback from the K by sigma T is a constant according to this theory, according to the classical free electron theory. So, but sigma is a conductivity, K is the thermal conductivity, but it is not a constant quantities. So, it is failed. So, means this is one of the drawback from the classical free electron theory. And also, according to this theory, the value of the electronic specific heat is equals to the 3 by 2 R. 3 by 2 R. R is the root mean square universal gas constant, and also but its actual value is 0.01. So both are not in close agreement. So it is one of the drawback from the classical free electron theory. The theoretical value of the paramagnetic susceptibility is greater than the experimental value. So means the ferromagnetism cannot be explained by this theory. So these are the success and the drawback from the classical free electron theory. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.